Super cool though, right? Super easy. If you forget the derivative of ln x, you can always eat both sides. But you won't forget the derivative of ln x because it's like all our other derivatives. You're going to memorize it. You're going to know it. I can already see, like, they're just like, yep, I can do that next one. I got that.
Oh, this was in the packet.
You're so smart, Corbin.
Derivative of ln x is 1 over x.
So, regards to that, how in the world are we going to do example 1?
Follow along. Yesterday, when we took the derivative of e to the x, it was e to the x. When we took the derivative of e to the u, it became e to the u times
U, derivative.
u prime, or derivative of u. So guess what? If ln x is anything other than x, what do you think we're going to have to multiply by? No.
The derivative of said.
Yep. And we're going to pause there so I got it. But, does that make sense?
In theory, I think that's just said no.
Alright, so what I kind of started to introduce is that, like yesterday, if we took the derivative of 1 over, or if we took the derivative of e to the u, it was e to the u times du dx. If you take the derivative of the natural log of u, and u inside is something other than x, then its derivative is 1 over u times du dx, or u prime. So again, this is kind of like u prime over u.
This is much less.
I want a nicer.
So end up just being U prime over the
Yes. So what is u? So u in this case is x cubed plus 1. So u prime is,
next square.
so the derivative of that problem is 3x squared over x cubed plus 1. Exactly. So this isn't terrible.
No, I can do this.
Yeah, I think this is easier than yesterday.
Well,
Oh yeah, inverse is the worst.
Inverse is wrong.
I think that's
What?
And
You eat. We were going to review on Monday too. We're going to review Monday, Tuesday.
Are we done? Like, this is the last
that's the last one.
Of chapter 3. Yeah.
one. We've been doing so much. Well, like, we did 0.
0, 1, 2, 3. We're going to start chapter 4 after Thanksgiving break. We're doing awesome. You guys are doing good. I'm like, yeah.
With 5 kids.
Yeah, I know. My mom said it's like you guys are basically getting like
One-on-one.
one-on-one like tutor time because you are open enough to ask like the questions.
I guess.
Now, maybe I don't know. What's the derivative of sin x? No, I think the other thing's right. Did you already do it?
Blaze is always
Oh.
So you have u prime over u.
I got the O on right
Or when you
before
said
yesterday.
Hannah, I thought she asked the question, what's the inverse, or what's the derivative of sin x? Wow. That's what I was like, dang. I know you missed that day. But
All right. So this is the square root of the ln of 2x. So it's a chain rule inside.
The chain rule in
So again, if it helps you, u is equal to,
2x.
so my u prime is equal to, so the chain rule says you start on the outside. So we start with the square root. So that's 1/2 ln 2x. Yep. The derivative of the inside, which is an ln, so it's u prime over u. It does simplify, so the 1/2 and the 2's could cancel, or these 2's could cancel. So then you get 1 over 2x square root ln 2x. Because it's all multiplied into 1.
What if I
That's it.
Okay.
You'd still get the 2 down there because you'd have the 1/2 in front still.
Okay, yeah, you're right.
I just like to cancel it the other way because it keeps that 2x as a 2x, so I see it more when I multiply. But it still works.
This is what you bring.
Yeah. All right. This is where knowing your properties comes into play. Because, yep. Because if you try to take the derivative right now, you have 1 over u, which would be 1 over a fraction, times the derivative of that fraction, which would be a quotient rule. Whereas if you use your properties, you can take the natural log with division and turn it into a natural log. Very similar.
Because I know here.
So now, when you do this, the rules are the same. Like the expansions and contractions. Now, when you do this, it's 1 over u of the first times u prime minus 1 over u of the second. So you actually do a quotient rule. So that's why yesterday we took that time to learn how to expand them and contract them. So you get 1 over x plus 1 times a really nice derivative. It's just minus 1 over the square root of x minus 2 times square root of x derivative, which is so then you get 1 over x minus 1 minus 1 over 2 square roots of x times square root of x minus 2. Whoa, sorry. Just my wording.
So technically, you definitely need to figure out more than a copy and just include the first and then divide it by the that exponent is over the whole thing.
Yeah.
That's cheating. Like it's
No, it's just my pen. Like, oh, you mean in your problem
Yeah.
it's over the whole
Yeah.
thing?
It's over. I was like,
Sorry.
wouldn't it be just 2 to the square
It
root
would
of
just
x
change this a little bit in here. That's all.
That's what I was wondering.
So it'd be x minus 2. So that one would just extend to the negative 1/2. So down here, but now, yeah, it actually does because since they're both square root x minus 2 square root x minus 2, so it's going to be x minus 2. Yeah.
But they would cancel out.
Because the square root is the same thing. Yep.
I was wondering where.
Sorry. Up here, do you see how like it
Yeah, I
didn't
know,
look
that's
like
why I-
it?
Yeah, no. I just when you started.
No, I'm glad you said it. You don't have to.
Would you want us to distribute
Hey, any other order. I'd take both. The reason I wouldn't get a common denominator is in case you took a derivative again. It'll be easier to have two quotients like this than one singular. Because the constants up here are 1. So like when you took your quotient rule, they'd cancel. Versus if you had one big one, then now you're going to have products and factories and stuff. All right. Then we have the derivative of the common log. Now that's why when you ask me like, are they the same? They're very similar, but they're not the same. You don't have So what I show you is how, like the purple is kind of showing how the derivative is what the derivative is. Taking the idea that the log base a of u can be used with the change of base formula like we did in our warm-up. So that would make it the natural log of u over the natural log of a. And it ultimately leads back to the idea that the natural log of a represents a coefficient because a is a number. So like when you take its derivative, it would become a 0 when you did the quotient rule. So like if you wanted to see the derivative of ln u over ln a, by technicality, it's O vi minus I VO all over O. And then what happens is that part zeroes out. So now you have the ln of A times u prime over u all over ln of A times ln of A. So that's how one of those ln of A's cancel. And then if you want to get your rid of your fraction and a fraction, you multiply by that's reciprocal. And that would give 1 over ln A times 1 over u times u prime. Or again, if you like to see it, 1 over ln A times u prime over u. And again, if you think about this, what's that represent?
natural log?
Or du. Yep. And that's pretty much all we're doing is we're adding just the first part.
Yep. You're just, if it's a log, the only thing you have to add to your derivative is 1 over the natural log of its base. So like if it was base 5, then it'd be 1 over ln 5.
And we can't cancel the ln.
No, because that's just going to represent like a coefficient. It's kind of like a constant.
You really can't.
They're all the same.
Oh,
Since when?
we at least do one easy one.
They're all easy.
Log 10 2 plus sine x.
Okay, this is use change of base to prove y. That's kind of what I wrote over there. Sorry. All right. It is easy. Okay, ready? Watch. Watch how easy it is. This represents the A, the 10 does, in the formula. This represents your U. So you need A, you need U, you need U prime. So what's the derivative of 2 plus sine x? Now you just fill into your formula. So dy dx equals 1 over ln of A, which is 10, times U prime, which is cosine x, over U, which is 2 plus sine x.
Is that it?
That's it.
We leave it like that?
Yeah.
We don't have to combine it?
Gross. I mean, the only thing you're combining is this. I was just taking a pause because I could feel it glitching.
We couldn't distribute that
I mean, it wouldn't help y'all. It's just a number. It'd be like if it was 4.
What if when I combine it, I put parentheses around ln?
Nope. You have to have the parentheses around the 2 plus sine x. Because the ln of 10.
Oh, no. I put them around the sine x too.
Oh, okay.
You just need a.
Who's writing it? Do you have like 3 sets of parentheses?
No, that's fine.
Oh, that's okay. That's fine. That's okay.
I did
Well, that's
Because
because
I
you're
had
messing
it
with the
over.
sign.
Well, it's probably has to do with the
Yeah, it
distribution.
was the
Because that's why I thought he was going to ask me if he could have them just around the ln of 10 and not around the 2 plus sine x. And I was like, no, because you have to have it on this.
Corey, you're so cool. I
So
get
they
it,
sort
sorry.
of have to whiteboard.
Wow.
Now, E represents a number, right? Yesterday, we said that the derivative of e to the u was equal to,
E to the u times the derivative of u.
so what's the difference from here to here? Yeah. Technically,
That's just the same thing as what we just did.
and technically, if this came down here, the A is the E. What's the ln of E? So technically, when you're doing the derivative of e to the u, it's really like a to the u, but because ln and e are inverses, you don't see it.
Or
Yeah.
But if there's a different
So if
base,
it's anything other than e, so if it's a, like if it's 3 to the x, then you have the ln of 3 in your answer. You'll see. Yeah. So it's 10 to the 2x. So just like the derivative of e to the whatever, it's 10 to the 2x times
ln.
derivative of 2 times, not 2x.
ln.
Yes.
Oh, that.
Yep.
Oh, yeah.
Because it would have been ln e. So now it's ln 10.
So,
Wait, can you go back?
Yeah.
Then why do we have? Oh, okay.
And again,
Did you know what I was trying to figure out?
Can we just leave it like that?
Because the order was different, you
Yeah,
were
then it was
confused,
like-
but then I realized you realized it was commutative, and
Yeah.
I was literally saying it, but I was drinking. But you figured it out before I needed the same
We
thing.
just leave it like
Yep.
that. We don't have to multiply.
Nope. Honestly, the only thing I would do, because like I don't like
I
the
would
look
pop
of
the
it,
2 over.
I moved it to 2ln10 times 10 to the 2x. Because again, in my mind, this is like the coefficient, because that's really, again, 2ln10 is really a number. And actually, technically, 2ln10 is really the ln of 100.
Well, can't you do 20?
No,
That's
no.
algebraic.
Because order of operations, it would be exponents before multiplication. So if you multiply the 2 and the 10 together, 10 to the 2x is not the same as 20 to the
Usually when
2x.
we combine it, it would be like 10x, not x.
Yeah, exactly. Yep. It's okay. You're thinking
Makes you feel better. I was going to ask the same question.
if you could make it 20. That's like that. That's
Well,
like the.
we could have if there wasn't an x.
Well, then we would just take the square.
Yeah, but
and
like
then-
it's kind of like when you used to like get a math problem and it would be like 2, 3 squared like this, and kids would try to say, oh, 2 times 3 is 6. So this is equal, like they would say they are equal to each other, but it's not, because order of operations say you square, then multiply. So it's really like 2 times 9, which is 18, not 36. So in the case of your problem, you were trying to say 2 times 10 to the 2x was equal 20 to the 2x, but like, no, like even if you plugged in x equals 2, I don't want to plug in big numbers for that. 10 to the 4 is 10,000 times. No,
Right.
you got me. All right. The next page,
That's really one class.
I don't know. Man. Yeah. I'm going to think there's probably like,
Crazy.
there's going to be like a witty or something on top of it.
Yeah, this little line.
And then I can actually like, see, there's a line there.
That wasn't for us.
I mean, it is, but I just want to like give you this real quick. We're going to do these problems now on Monday, but because I haven't worked with the old textbook, so like you can't use the problem number, page number. These are the steps you want to take if you're doing a log. So I'm going to think your homework's going to be very similar